Okay, so we're going to look at Lisp, and I've already given you a tour of Lisp, and you've started on your implementation, so you understand Lisp to some degree there. And if we were to just look at, programming in Lisp, that introduction I gave was probably enough for you to go to the Common Lisp manual and go and understand how Lisp works. Okay. So what's going to be different in what I'm going to talk about is that I'm going to actually talk about implementation. Okay. I'm going to not talk about something that hopefully wake Nathan up. He has been anxious to know how this is resolved for a long time, but today he's quieter than normal. It has to do with setqs. A long time ago, I told you that setqs in function bodies, in lambdas, are just disallowed. Okay, so we didn't even consider the case of what happens when lambda does setq, because we said that's banned. Okay, and that's, functional programming, it should be banned. Okay, pure functional programming. But again, just to complete it and give you more things to implement, let's go and try to figure out what setq does or should do when it occurs in lambdas. Okay, so let's try to understand this, and what we do here should not be totally inconsistent or much inconsistent with what we know from Java-like languages. Okay, but let's consider many cases. So I've got a global variable called x assigned 3, global variable called y assigned 5. I've got a lambda that takes x as a parameter. So x here shadows the global x. Okay, and so far we never did a setq in a lambda. Okay, and this lambda returns plus xy, where y happens to be a free variable, and I do a setq xy 5, and then I do func call f2. Okay, what do you expect to happen? Print out what? Is it 10? Okay, it's 10. Okay, and in printed out 10, and if I go and type x after I call the function, what should happen? The x changed in the local scope, not the global x did not change. It's not 5. Okay, so the definition seems to be, we are just going through examples in order to figure out what the semantics are. If assigned variable is not a free variable, that is, exists in local scope, setq assigns to it. Okay, this is not what is happening. This is not how assign works today in our environment. So we'll have to go and change our assign so that it does that. So I don't know. I'm not sure what assign does right now because we just banned it. Okay, it might be doing this, but this is what we need to do now to be consistent with.
So the question is how are we wanting to scope setq? Should setq be a end-all, be-all, set this environment variable outside and inside?
Okay, so we're considering many cases.
Or would it act like a function where we have our own variables? If I made in Java, I made a function E, and I made a variable A, and I tried to call A outside of that function, I would get anything that doesn't exist yet. And the question is, do we want to be treating setq like that, or do we want to say, tell the machine that no matter where we are, set is true?
Okay, so I'm not quite sure what you're saying, but I'm going to go case by case. Do you understand this case?
Yep.
Okay. I haven't told you the full definition. Let me tell you the full definition, then you can come back with your question. Andrew?
Yeah, I think, I can't really interpret that. I think what he's saying is it like var in JavaScript, where if you have var outside a...
So you're going outside. I don't want to go outside right now gradually. I'm right now inside. You guys understand this part? Okay, good. Okay, how about this? I have setq x5 plus 5 in a let. So there are 3 scopes now: the global scope, the let scope, and 2 scopes. Okay, and I've got let x2, setq x5 plus xy as the let expression. Okay, what should this let expression return? 10. Okay? And if I type X again afterwards, after the latest finished execution, okay. Same rule as before. If a signed variable is not a free variable that exists in local scope, setq assigns to it. Okay? Now let's talk of a free variable, what you guys are getting into. Okay? And free variables can be resolved in two different ways. Just remember that. Depending on your whether it's a lambda or a function, the parent environment can be the defining environment or it can be the calling environment. So that's an orthogonal issue. Okay? Function versus lambda is an orthogonal issue. The question really becomes now that I've got x and y, they're both free variables, they're both global variables, and I've got setq f lambda x setq y2 plus xy, and I'm setqing a free variable rather than a local variable. Right? And I do funcall f4, the value should be so 4x is true, and y has been is going to be 2, so it will be 6, right? So again, we are going to a parent scope. Whether that parent scope is a calling scope or the lexical scope depends on my environment when I'm evaluating it. It does not depend on setq. It depends on the environment that setq has been passed. And that could be the lexical environment or the calling environment. And that's an orthogonal issue. Okay, that is not something to do with setq. Okay, it is the same problem occurs in lookup, and the same problem is occurring in assigning, and so that's what happens. Okay? If I type y, it's still it is now 2, because I changed a global variable. Okay?
In a previous example, you did the same thing.
I setq'd x then. Now I'm setq'ing y. Okay? Now let's take the case that is the most confusing. I am now going and setqing z or z, which has not been defined, which is not defined in my local scope, and which is not defined in the global scope either. And this is the part that is the most confusing, and what you guys should think should happen here. So firstly, what should be the result of this? What happens if I type this at this point?
Well, it depends on how we want to do it, but I think error, if we're using this like functions. So I think it should be error. I think it might, in actuality.
No, so if it's an error, that means what? It defined, if
If the Z was only defined in the environment that it lived in.
okay. So your interpretation is that if it is not defined anywhere, define it in the most local scope. That's one definition. Okay? Is that what you also think?
Well, you said it's going to be confusing, so I get the feeling it was defined in the main scope.
So, no, but the non-confusing part would be this.
So I feel like the reason that the fun exists is to make it so that if this example were to be defined, I feel like
Define versus setq is just function versus non-function, different space, you know. So, but you're saying define is normally in the global environment.
why is it that we're using lambda functions as if they're functions, as if this were in Java? If I were to use Java, then I would get an error, but here we're not.
Yeah, so that's the trouble. When things are not defined already, this is when things become confusing. Okay? And it's confusing to me too. Firstly, the Lisp I learned, when I learned Lisp, the setqs were not these banned things. They were just bad things to use. Okay, because I learned it as a language, not as from an implementer's point of view. Okay? And there was setq and there was csetq, and I could never remember that. And decades later, I because I had to memorize, I don't know what it was. Everything else I can derive kind of in my head. So it's 2. So from an implementation point of view, it's kind of nice. You just keep going up, just keep going to your ancestor scopes. And if you end up with no variable, whichever scope you ended up at, that is where you end up defining. Maybe that's the reason. But I believe, based on how I've seen you guys write your solutions in the exam, most of you believed, a lot of you guys use Setq in your functions, even though it was banned. And you probably assumed that it would be defined in the local scope. Okay? So if you really want the variable to be defined, you should have done a let. You do a let, and then go in, because that would define it in the local scope.
So like I thought of this like a while ago. So in order to implement something like this to work, would we want Setq to always go to the root?
Just keep going up.
Just always go.
Keep going up till you find the value. And if you don't find the value, you would be at the top environment. In that environment defined. And if you really want something in the local scope, we have let.
If it doesn't exist in this environment, keep going up.
Yeah, until it either is defined somewhere else.
Yeah.
Or you get to the top.
Yeah.
Okay?
Okay.
And again, let is the one that you use for the local scope. And since they have a let, and since they allow, I mean, I would probably ban this kind of Setq. Okay? But there's all these issues.
If we wrap the lambda in a function, it's going to be the same thing, right?
Yeah, it'll just go up. The path it will follow will be different. It'll go up the lexical environment, but the effect is the same. So you don't have to go and change. Okay? I'm kind of saying in words what I said earlier. Okay, I put all this text here so that when you guys can look up the PDFs and not have to listen to recordings. Okay, so that's our Setq definition. I'm just combining the 3 things I said earlier into one definition. Okay, let's now, that's the language implementers had. Let's look at the language designers had. This is kind of stuff actually I cover in 110. But I've got 3 functions here. And I talk of purity of functions. So a function in a programming language is pure if it's more like a mathematical function. And it's impure if the more it deviates from a mathematical function, the more impure it is. So which here is the most impure, which is the most pure, and which is in between? Chris? Right one is the most pure because okay, so the lack of free variables, the existence of free variables makes it more impure, right? In mathematical functions, there are no free variables, there are no scopes. So why is the middle one or the left one? Let's compare the left one and the middle one now. So the global variable is the middle one is computing a value, and the left one is taking the value and assigning it to a variable. Left one is better? It's like a setter.
That would be a setter where I have a function that exists just to set a single variable.
Because the left one is like a setter,
That's a setter.
and the middle one is like a get. Well,
I don't want to say that again. That's just
No, it's relying on the next value being set elsewhere outside the function.
yeah. So the middle one can fail. The middle one can fail. Right.
The middle one is set.
The middle one can fail. The middle one's can fail. Sure. What? Why? Oh, it sets it. It doesn't get it.
no, it's got to evaluate. It's got to evaluate the right-hand expression before it.
I missed that. You're right.
It's not trying to do anything meaningful. I'm just trying to show you the difference.
Well, I know, we're just trying to equate it to things.
Yeah. So which one do you think is nicer or more pure?
It's still the right one.
So it goes right to left, right? And what exactly is the problem here? Let's go in. Yeah, side effects. Right. So which one has side effects? So let's assume that X has been assigned before. Okay, what confusion can occur? So Robert mentioned side effect. Do both the left and the right and the middle one have side effects? Or no. The left one has side effect, right? So side effect means what? Side effect means that something that you didn't expect happened. You know, the main goal was something else and something else happened. Okay? So let's say I do func call F2 here, okay? And it's 5. Is that right? Yep, 3 plus 2, 5. If I do func call F2 again, what will be the result? That's kind of funny, right? I call the same function with the same arguments twice in succession with nothing in between, and I get two different results. Okay? So that is, you know, that's like as bad as you can get in terms of functions. Okay? So you're changing free variable. That's side effect. Here, if I do func call F2 here, I get 5. If I do func call F2 again, sorry? Okay, but I put a little space between this func call and that func call. So I can get here 4 if so if I call the same function twice in succession with nothing happening, I get the same result back. But something in between happens. Okay, so it's better than the left, but the right one, no matter how many times you call it, it's going to return the same result each time. The rightmost one. Okay, so that's a pure function. Accesses only locals. Okay. So Setq inside lambdas can result in side effects if it's accessing a free variable, and so that's why C Setq problem. So you might say that we shouldn't have any side effects. And have you guys ever implemented or used a function with side effects? What's a function that everybody has used maybe? Setters don't return values. But no, if it's a procedure, it's not, by definition a procedure has side effects. A function is something that returns a value and makes a change. That's why things get, yeah. So plus would be an example, very good example. What about in like 110? I told you I taught this in 110. What's a function that in 110 students would always have to use to do anything interesting? So you can, 110 assignment has print is a procedure. But what's the opposite of print? Good. Hello world. You can print hello world or read. And what's the side effect? Each time you read the line, you go to the next line next time. 2 read lines will never return the same value. Okay? Anything else? Iterator? Lots of students have trouble with iterators. They do next in succession. They want to get the same value again, they do next twice without, and you get different things. A good old stack. Okay? So, remove. I meant to say, wow, look at the way I type now. I meant to say list.remove. And my finger's just obsessed with Lisp right now. factory object, when you do create, it returns a value. And so here's what I tell my 110 students, and this is running up time, is that name suggests side effects. So this is not confusing. If pop was called get top and it removed something, you'd be very confused and mad. But because it's called pop, you're fine, okay? And useful impure functions with no side effects, your getters. Your getters are examples of functions that are impure but access free variables. Okay, we'll carry on from here next time.